Good evening, everybody. Welcome to Meteorology Lab. Thought it would be kind of fun to put this footage up. Didn't get any drone footage today, so we're just kind of rolling with this, but the sky looks very similar to what we had when we flew the drone on that day. So there's the Doubletree parking lot. All right, heading out to the charts. Let's check it out. We've got a front moving into Texas, a little bit of spring weather, and you can see that baroclinic zone has pushed across the Rocky Mountains, and there it is right there. Let me see if I can make this pan a little bit larger. I'm not too sure how to do that. I switched computers, so I'm still trying to figure this out. Anyway, the leading edge of that front looks like it's definitely through New Mexico there, and pushing into northwestern Mexico, right around Guaymas. I'm not too sure of the Mexican city names. And then the warm front looks like there might be something up north around Kansas. And I'll show you something else. You see the isobars, this line right here in Texas. It's hinting at maybe a little bit of something right in this area. Now, we talked yesterday about the... Before I get into that, let me make sure audio is good. Okay, great. Yeah, we talked yesterday about the supercell, the significant tornado parameter. Let me see if I can bring up that diagram. That's not it. A little bit further. Should be right in this area. Okay. Significant tornado parameter. I mentioned how sometimes this can inadvertently identify boundaries. Now, we can definitely see the zone here indicating dry line or a front, but there's also this kind of congested pattern over central Texas. So this is how it looked earlier. You can see that zone right there. So what might be going on in that region? Significant tornado parameter. Let me see if I can pull up a definition of that. Significant tornado parameter. Yeah, so here we go. You can see we're looking at Cape, so that's basically instability. Okay, this whole term here is all instability. So the greater the Cape, or even kind of like the Lifton index, that's going to multiply it and make the value higher. We also have LCL, and we have a subtraction here to indicate that the lower the LCL, the better the chance of severe weather. So that makes this whole term go up. So LCL is another indicator. Also storm relative helicity. So the higher that is, the higher the storm, the significant tornado parameter. And then we have the bulk wind difference. And then we have convective inhibition. So that's how capped we are. And this is a relatively simple parameter, because you can see it's a multiplication, one term multiplied by another, so it's pretty easy to kind of get a feel for what might be bumping the number up higher and so on. But for some reason, this seems to identify boundaries very well, especially on the high resolution rapid refresh. So that area in central Texas, what did that look like? Let me go over to the surface chart. This is how it looked earlier today. You can see that's an 18Z chart. So this is all Texas here. And we look at San Antonio, 75 over 63, so that's very tropical looking, a lot of marginal VFR. What about northeast Texas? Okay, we're in the upper 50s, drier air, winds out of the east. So there's definitely an air mass difference. So we start looking at the data out in East Texas. Well, in Houston, we've got 75 over 68. So the air mass contrast is between here and here. And what we're interested in is the warm side of that gradient. Okay, 73 at Huntsville, that's still kind of the tropical air mass. And then we hit 68 around Crockett and 67 in Palestine. So we're definitely dropping. So this indicates that we've probably got a boundary in this area, and this probably links up to this system that's out here along the Cap Rock. So in this instance, it can be very important to trace this boundary back and see if that connects back up to something in this region here. So let's look at the data out around Brownwood. 68, that's kind of mild. 64, we get cooling and a little bit of southeasterly flow. I think we're probably looking at something. Yeah, I'm probably going to go with something like this right here. So there's some sort of very weak warm front. And if we had severe weather, if we had less capping, this could have been a very important area. There could have been some locally enhanced shear right in that area, low-level shear, not bulk wind shear, but actual helicity. So this is kind of an area you have to watch when we have a day like this. And you can see as we get up north in Oklahoma, the air mass gets a whole lot cooler. So that really identifies Texas as being a potential supercell area if we had, if we could remove that capping and get some more instability. So anyway, that's what we're looking at, and that probably ties in somewhat to what we see with these enhanced patterns right there. And also, it's definitely the instability bumping up this value here. It's just flat out unstable, and the cap is probably a little bit weaker, whereas down here the cap is a lot stronger, and that's minimizing the significant tornado parameters. So anyway, let's move this on. I'm going to try to, no, I'm not going to, I don't think I'm going to grab the current data. Let me get that from SPC. Okay, we're going to take a look at the surface chart there at SPC. And these are going to be the current conditions at this time. So as we can see, not really anything fired out there in Texas and Oklahoma. So it was kind of a bust day. And what happened to that boundary? Looks like it might have drifted north a little bit. Looks like it's just north of Palestine and Lufkin, kind of in this area. So we go from upper 50s here to tropical air down to the south. Okay, then the dry line itself, well, that's going to be out in this area here. Wow, 6-degree dew point there at Childress. The dry line is definitely through there. Okay, so there's our dry line. And then the cold front out to the west. We've got a Pacific front moving in. Where is that going to be? I'm guessing, well, we go to the west, 67, 64, drops off very gradually, and it's very hard to find there. Also, we have the issue of the air mass cooling off. It's very difficult to find cold fronts out in this area at nighttime because of that, unless they're unusually strong. So I'm probably going to go with roughly a position like that, somewhere in here for that cold front. And we can identify that with other data, such as, of course, velocity tensor magnitude. Does it show up? Not really. But we've also got the theta field. Looks like something's going on up there in northern New Mexico. So maybe that cold front is actually way back here. And then we've just got this dry line out there along the Cap Rock. So that's basically the surface analysis in this part of Texas. And let's link that up with the large-scale pattern. And we link that up when we can find the right Firefox tab. There we go. Okay, so we've basically identified some sort of warm front boundary in here. We've identified the dry line somewhere in that area here, and then the cold front looks like that is going to be back near Albuquerque up to Denver. Okay, so that's the surface analysis, and you can see the cold air is definitely moving into the Great Basin region. Elsewhere, up in the Midwest, warm air advection patterns setting up in that region here. And out in the East Coast area, some residual cold air advection affecting Pennsylvania, New England, and New Jersey there, Maryland, and even Virginia. However, that big ridge is going to be moving into the region. Okay, continuing on, let's look at the upper air pattern. And let's grab the latest chart. This is the 250 millibar analysis. This is going to be up at about 34,000 feet. So we can identify the subtropical jet. It appears that's pretty far to the south there. And we know that that's a subtropical jet because that Pacific front is way up in this region here. So the support, the thermal support for a polar front jet does not exist down here. So we know that that's subtropical jet. Or can I type text? Let me see if I can try it. Yeah. Oh, that's cool. I don't think we've ever done that before. Okay, subtropical jet. And then up north, we do have the support for polar front jet. I'll give a different color for that. So that's going to be our polar front jet out in the Four Corners area. And then there's, of course, another segment out there in Pennsylvania and the Great Lakes. So that's the upper air pattern. That's how everything ties together in the vertical. And one final chart we can look at is the 850 millibar. That gives us our surface moisture. And we'll take a look at how it looked this morning so we can see the setup that we had earlier. When we use this chart, we've always got to check and see if we have dew point depression or dew point. And the way we do that is we look for negative values. You're not going to have a negative dew point depression. It's always going to be positive. So we've got minus 25 there at Detroit and minus 28. So this is dew point. So we take that and look at Texas. We've got dew points up to 12 there at Fort Worth. It's going to be about 54 Fahrenheit. So there is some decent moisture flowing northward. And if we do just a very quick isodrosotherm analysis, there's 12. And then 10 is going to run something like this, all the way to Shreveport. And then it looks like it comes down to Corpus Christi and then goes around Brownsville, kind of like that. So the main feed of moisture is running up the Rio Grande up to between Abilene and Fort Worth there, maybe up to Oklahoma City. So a little bit of a 30, looks like 30 knot low-level jet, kind of a mild jet, bringing up some weak moisture and definitely not enough to support convection. In fact, let's take a look at the satellite and see how that looked earlier. In fact, I think I've got some visible imagery. Okay, so here is Oklahoma earlier this evening, and this is where we tried to get some thunderstorms going, but it doesn't look like really even any deep convection. So all you see here is stratocumulus clouds dying off as we lose heating and getting higher up in the troposphere, or the lower levels. And didn't get anything going. Let's look at the soundings, because that's actually the story, how things were set up. Okay. Fort Worth sounding, don't have one for this evening, but we should have one for earlier. And this is how the diagram looked this morning there at Fort Worth. Some fairly decent moisture all the way up to about 8,000 feet. That's fairly deep. And looks like some of those dew points were up around 60 degrees, in fact. But here's that cap there, up at about 10,000 feet. And that kind of keep things shut down. Couple that with a 73 degree temperature. And the parcels looked like this right here. So there's our capping. That's probably definite. Well, that's certainly a factor right there. If this is peak heating right here, we're probably not going to break that capping you see there. And if it did, not much cape really. We would have needed not only the cap to be removed, but we would need steeper lapse rates up in this area to really bring that cape up. So this is a very marginal support for thunderstorms. Okay, satellite, this is the infrared imagery. So it looks like we got a little bit of upper air energy moving through. Down below we can see the low clouds right there. And I noticed this weird little feature here. Wonder what that might be there. Let's take a look at an enhancement. This is a different color enhancement curve, and it is showing that little feature right here. So it definitely has the appearance of some sort of cloud, but we didn't see that on the visible imagery, so that it seems like kind of an enigma, but we have to go back to the basics and remember that this is temperature. So chances are we're seeing maybe kind of a warmer ground temperature in this region, maybe a little bit cooler, and out to the west, and there could be some attenuation of moisture in the mid-levels going on there. Let me take a quick look at the surface chart. I was going to see if we could explain that little feature just based on the data we have right now. So I'm looking at temperature here, and temperature does look a little bit warmer out in this area. So that could be some of the moisture actually making it up to the satellite. I think that's what we're seeing. And then further out to the west, yeah, what's going on out there near Amarillo, out in this region? Kind of has the appearance of cloud, doesn't it? Well, if we animate that, doesn't look like anything moves. So it looks like we're looking at the ground in this area, and we're seeing different ground textures with different levels of long wave radiation in that region. All right, let's see here. I'm going to set up the water vapor imagery, and we can take a look at that real quick. And let me take a look at chat and see how things are going there. I have to move my window around. Okay, very good. Pretty good crowd tonight. So I'm going to skip very quickly through a lot of this chat here. Ryan Toomeys, Ron Chalfant, Adam Davis here, Megan John, 37 in Minnesota, wow. Jeff Krob and Burl H, Shirley Keast, Erica Baker, appreciate the comments. Electric Dog, Fun with Tech, Mr. Manlet, 36 degrees there. Ryan Toomey is reporting marginal risk coming up for the Midwest. Sue M is here, and Kathy Campbell Wallace, snow in the Bighorn Basin. Mike Estwick is here, reporting a 25-degree drop in that region. Mike Estwick asking to check service desk email. Okay, we'll do that. And very good. Okay, we'll keep it going. Looks kind of busy out there in the eastern Pacific. We've got a couple of pretty good waves in this flow right here. Another one out there near Hawaii, just east of there. And this big upper level low just kind of spinning out there south of the Gulf of Alaska. So quite a lot going on there. So let's see here. What chart are we going to go with next? I'm going to take a quick look at the mesoscale. And we'll take a look at Texas. And maybe track that little front. Maybe see if the NAM is picking that up. This starts off this morning at 12Z. So we can see out to the west. Cooler temperatures, and that's largely due to the drier air in that region. The cold front, keep in mind that cold front is way out to the west, probably out in the Four Corners area. So even though it looks colder on the high plains, that's not the Pacific cold air mass. So you kind of have to keep that in mind and use kind of a bit of common sense as you look at all the data. And then out in this area, we've got both warm air advection and moisture advection. Once we warm up, things get a little bit easier to find, and we see some interesting temperature contrast. Looks like the dry line shows up. It's got kind of a wavy appearance, and there's a bit of a gradient associated with the warm front. Looks like it's in that area right there, and it possibly loops around maybe something like that right there. So a little bit of non-uniformity setting up that warm front boundary. As the evening goes on, we run this up to the current time, and it looks like that right there. I think probably that cold front is right in this area here around Las Vegas, New Mexico, down Albuquerque. You can see the northwest winds back behind that. And let's run that forward overnight. And this would be the area to watch right here. We can watch for evidence of the front coming into the Tucumcari Amarillo area. And it looks like that could be it right there. You see the northerly component in that region right here. That contrasts with the westerly component in this region here. So that's probably that cold front coming out. And this is around 2 in the morning. So very strong advection of that front, pushes on out to the Caprock around dawn. Things warm up during the day tomorrow, and it looks like around 9 a.m. that boundary makes it all the way to Dallas and down to Brownwood and San Angelo. So with that in mind, we have to keep in mind that as we get the heating, we have to watch for thunderstorms. Maybe the cap will break. So by 2 p.m., looks like that boundary runs from around Marshall down to Crockett and down to Austin and San Antonio right there. So it looks like a chance of thunderstorms in this region here. And then that boundary moves on off towards Houston and Baton Rouge down to Lafayette, and then by the overnight hours, it's already approaching New Orleans there and moving offshore. And back behind it, it looks like some cool air moving into the Texas-Oklahoma area. So, you know, I know that this is kind of Texas-centric or South Plains-centric, but what I'm kind of doing here is teaching you all concepts that you can apply to your own region. There's no way I can cover the entire U.S. since that would run this program probably over an hour. But with something interesting like this going on here in Texas, yeah, we're definitely going to cover that. Okay, let's head into the forecast. And we'll look at the NAM here. We already saw some of the NAM, so we know that that front is going to be pushing in East Texas tomorrow night, or tomorrow afternoon. And let's check out the dew point field. During the day tomorrow, the setup is going to look like this here. 60s dew points all the way up to Dallas and up to southeast Oklahoma. So dew points are going to be running in the mid-60s in this region here. So by peak heating, that's the setup right there. One thing that we do notice is that there is not a source of point convergence. It's all fairly linear. So this is probably going to favor some linear storms if they get going. And then we can set this out in the moist sector and look at a sounding and get an idea what that cap looks like. So yeah, looks like the cap is fairly weak compared to today. Not much capping either. And it looks like we got a little bit of cape there, so yeah, we do have probably some potential there for storms. And if they move off the hodograph, we get a good southeast motion there that will sweep out a fairly, well, not much sweep there. You see the problem here? Let me see if I can zoom that in. We're looking at the hodograph there. This is a plot of forecast winds. And you can see there's the 0 kilometer wind. There's 1 kilometer and there's 2, and there's very little difference. And if we try to sweep that out with a storm motion, we get very little geometric area. So there's very little 0 through 1 kilometer storm relativilicity. There is 0 through 3, so that area gets swept out there. So it's all going to come down to whether we can separate this 0 through 1 kilometer flow. And one way we can do that is to actually have a low-level jet set up, and that pushes the 1 kilometer point kind of out in this region here. Because naturally, if you have a low-level jet, you're going to have a wind speed of about 30 knots, maybe a flow out of the southwest, for example. Meanwhile, the surface wind would be kind of weak, and it would be in this area here of the hodograph. So that would help sweep out a larger area. So what we would need is a mesolow or some sort of unforecast upper level wave moving through the area. There's no way to really know till tomorrow morning whether we have that set up, but that would be something to look out for in the forecast tomorrow. But just looking at the raw model data, that very poor 0 through 1 kilometer storm relativilicity would be a problem. Let me see if that shows up in the table here. SRH, surface through 1 kilometer, only 18. That's very, very low. Okay, and you can get an idea what the contributors are to any tornadic cells. We look at this chart here, the effective layer storm significant tornado potential, and we can see that the coefficient that's the highest is LCL, and definitely we've got 68 degree dew point there, 71 temperature. That's going to be a very high relative humidity and very low bases. So bases way down low, hundreds, maybe 1,000 feet there. So that would be the main contributor there. Also some CAPE, and the rest of the other values are kind of on the low side, like E, effective bulk wind difference, 0.6, that's kind of low. And that's because the upper level or the mid levels are only about 40 to 50 knots. There's very little bulk wind difference there. And let's move on and look at the forecast. I'm going to give you this chart here. This will kind of show you how convection breaks out. Looks like a little gets going around Palestine and Jacksonville, moves into East Texas. Very fast moving, and it looks like by dinner we'll see it from about Lufkin up to south of Monroe. So it looks like mostly Louisiana will have the better convection, and then the scraps there in Texas. A little bit, I guess, tries to get going around Caldwell, College Station out in that area. So convection moves eastward overnight. Looks like a little small MCS gets going in southern Louisiana. And then things kind of move east and offshore, and then the ridging starts building in. And here's a look at the significant tornado parameter. Looks to be kind of on the weak side there tomorrow. So yeah, looks kind of marginal for tomorrow there. And yeah, I'll give you your mixed layer cape for tomorrow. Those values are about 1,000, so that's enough to get thunderstorms going, but not much more than that. Okay, let's move on and check out the hemispheric. Got several long waves. There's one off the East Coast, another in the Pacific, and then some others out there in Asia. So it looks like kind of a 5-wave pattern set up. And they do look, I'm not sure if they're progressing, but here's this big upper level low that we saw in the satellite way out there in the Pacific. Looks like we're going to have... This is one way you can assess the severe weather potential, is to look at the curvature in your area. So whether it's anticyclonic or cyclonic. For example, let's bring this up to Thursday. You can kind of see there's kind of a weak cyclonic motion there, but it's out of the northwest. So this indicates probably kind of a dry pattern. And then we get this ridging building in Thursday night. And then the flow starts changing to kind of a cyclonic pattern here around Saturday. So that would indicate probably some potential for storms there. Ridging builds in. You can see this ridge right here across the plains, so things will probably shut down on Sunday, a week from now. And then a very strong trough moving onto the west coast. And that crosses the Rockies and ends up there in Texas on Tuesday. So probably another chance of thunderstorms around Tuesday. Another wave comes into the plains for Saturday. Friday or Saturday there. Another wave coming through around Tuesday. So things look to be getting kind of active there coming up for mid-March. So that brings us to the forecast. Cold front is going to move into Texas, and there it goes. And then the other half, which we haven't really talked about, moves up into the Midwest. So here's the setup for tomorrow. It looks like an occluded front coming up into Minnesota there. Some snow around Minneapolis and curving around back towards Aberdeen, South Dakota. This low kind of occludes and starts decaying the main baroclinic zone as well to the south. So not much is going to be going on up in the Great Lakes. We get kind of a weak wave developing there in Georgia for Tuesday. This low here continues to spin, and a little bit of unstable air in that region kind of drifts across the Midwest there, and then we see the southern part of the system moving up the west coast or the east coast. There it is on Wednesday. So a little bit of rain and maybe a bit of snow there in upstate New York. And then after that, kind of a quiet pattern, just high pressure building in. And then we start looking out to the west. System coming on shore for Thursday. And looks like it's crossing the Rockies right there on Saturday. And then it appears something emerges out into Texas around Saturday there. So we're looking maybe somewhere in this area here. Looks like a bit of cold air building up there in the Central Plains, so the pattern looks kind of like that. Looks kind of like a inverted trough there in Arkansas. And all of that is going to kind of curve the low-level jet like this and support activity in this region for Saturday night. And then cold air builds into Texas over the weekend. And then we start getting those waves coming in there from the Pacific and interacting with the frontal boundary. And it looks like the first convection is coming in for Tuesday and Wednesday. There it is right there. But we got to keep in mind there's this big 1030 millibar high over the Midwest, so the flow is going to be kind of cold in Oklahoma. So this kind of suggests the idea of elevated storms in that region right there. Maybe a bit of high base convection, and you can see it kind of fall apart right there. Another wave comes in later in the week, and looks like that goes mostly up north. And then another big system coming out of the Rockies for Saturday, for Friday and Saturday. And there it goes. This is 300 hours out, so there could be a lot of change between now and then. But it definitely looks active coming up there later on. Okay. Yeah, everybody talking about the text there. I'm going to use that more if I can figure out how to downscale the font. And let's see here. Let me look through the chat. Okay, Jeff Krob asking what defines the top of the inflow layer. I believe they look at the layers that are buoyant, and there's a specific definition. Let me get that for you. Effective inflow layer. Yeah, there's a very good page here that explains it. Let me make sure that this is showing. This is on the SPC page. If you go to their experimental mesoscale products, you can click on this, and you can see that they're basically working up the sounding and looking at parcels that have over 100 CAPE and convective inhibition above 250 there. So that's basically how you do it right there. So that kind of weeds out cold parcels near the surface and parcels that are very well capped. Okay, well, I think I'm about talked out here. We've done 41 minutes. Time really flies. Yeah, it's about all I have for tonight. I appreciate you watching the webcast. Hopefully we'll get my cursor back there. There we go. All right, thanks for joining us, and we will see you tomorrow. Take care.